Hey there. My name is Arturo Rosales, and I'm gonna be going over the 12th problem of the procedure section of the first partial lab. And well, all right, let's get started. So we have here that limit as x tends to infinity of 3 plus x minus 2x to the third power over x squared minus 5x plus x to the third power. So there's a couple ways to do this, right? I actually went ahead and wrote down the shortcuts here. So we have these shortcuts, right? And we can get to the answer really, like, these shortcuts, I mean, allow us to get to the answer really quickly and really easily. But I know sometimes, I mean, we might get asked for the full thing, the algebraic method during a test. So I'm gonna be going over both of them. So we have here that I went ahead here, for starters, I just rewrote it. I literally just rewrote the same problem here, right? And then here I rewrote it as highest power to lower, and then to be able to determine the whole thing, right? So here we actually do have equal degrees down here and up here, meaning we would go to this rule right here, being the ratio of the leading coefficients. But considering the algebraic method, we would go we would go ahead and start with is first of all, I wrote down here step 1, dividing every term by the highest x power in the denominator. Okay, so here is the highest x power in the denominator, being x3, right? X to the third power, I mean. So what you do, like what we would do, is go ahead and list down all the same values divided by that highest power, and go ahead and simplify them, right? Because you have a bunch of x over x, right? You can cancel that. We know algebraically you can cancel that. So we're left with an equation looking like this, and I went ahead and crossed it out because later on you can cancel those and basically turn them into zeros. So yeah, I went ahead and I listed it all down, and then what we do here is we go ahead and consider all these zeros, and we're left with -2 over 0, right? So then step 2 is actually that we canceling any term with a variable in the bottom and a constant on the top. It has to be that way. It has to have a variable in the bottom, in this case being x, most of the cases being x actually, unless applications is considered, but let's not talk about that. And the constant on top, right? So we make those zeros, and we get -2 over 0, right? -2 over 0, that's the point. So we get this, -2 over 0. And then we're left with limit as x tends to infinity of -2 over 0, right? Which, if we just consider algebraically, I mean, -2 divided by 0 is 0, leaving us with a final answer of 0, right? And if we were to have done it with the other method, as you can see, I mean, here it's -2 over. So yeah, that's about it. Thank you.
Hi, my name is Jorge Contreras, and I'm gonna explain problem 62. It's a derivative, which we're gonna solve using the definition, meaning that we cannot use chain rule. So to starters, this is our base, and what we're given to. What we're gonna do is substitute each x with x plus h. So every x is gonna be x plus h, meaning that the formula will be looking like this. It will be square root of 1 minus 4, open parentheses, x plus h, close parentheses. Then what we're gonna do is subtract by the original formula, which is square root 1 minus 4x, all divided by h, meaning that it will look something like this. 1, 4, x plus h, close parentheses, minus the original formula, which is 1 minus 4x, and all over h. This is when h tends to 0. Remember that. Now, we're not gonna put attention to the x tends to 0 yet. We gotta simplify this. So right now, if we plot the 0 here, it's gonna give a wrong answer because it's not completely in a correct form. So what we're gonna do is we're gonna get rid of these square roots on the top, and by doing that, the formula we're gonna use is that everything that we multiply on the top, we're gonna multiply on the bottom. So we're gonna multiply the top base, which is the 2 square roots, and we're gonna multiply those by the top and divide by the same thing. So it's gonna be something like this. 1x. So I'm taking down, I'm copying and doing this formula. So basically, the formula we have up here on the original problem is going to be square root 1 minus 4x plus h minus square root minus 4x all divided by h. And then we grab this part and multiply it in a whole, this is just added. We multiply it on the top, and everything we do on the top, we're going to do in the bottom. So also we're going to multiply that h by the base formula. So it's gonna become something without the square roots on the top, but it will have square roots at the bottom. So it will look something like this. So I'm taking long. I'm repeating, I'm copying everything. So now we're gonna have this 1 minus 4, open parenthesis, x plus h, close parenthesis, minus, open parenthesis, 1 minus 4x. And here in the bottom we're gonna have h, open parenthesis, this whole formula we had before, which is square root of 1 minus 4x plus h, plus square root of 1.1 minus 4x, everything. This is a plus, because since we have a minus on the top, we're going to have a plus on the bottom. So now we're going to simplify. We do a FOIL method. So it's going to become something like this. So it's going to become something like this. Minus 1. So now here we're gonna have 1 minus 4x minus 4h, sorry, minus 1 plus 4x. So here this 4x and this negative 4x erase completely. This minus 1 and this positive 1 erase. So we're left with 4h over h and square root of 1 minus 4x plus h plus square root of 1 minus 4x. So we're left with this, and here each h is gonna be completely eliminated. We have an h on the top and an h on the bottom. Everything is left out. These parentheses open up since there's nothing to multiply them, and we are left with negative 4 over square root of 1 minus 4x plus h plus square root of 1 minus 4x. We're left with this. And what we're gonna do next is simply, now we're gonna tend to 0. Remember that 0? So limit, well, h tends to 0, and every h that is in the bottom, every h that is here in the bottom, we're gonna put a 0 on it. So it's gonna become negative 4 over square root of 1 minus 4x plus square root of 1 minus 4x. Now, these two on the bottom are the same. So what's going to happen is when you have two same of the same formula and it's a square, it's going to become 2 square root 1 minus 4x. Okay? So it's going to become like this because you have the same thing. So it's gonna, and it's adding, so it's going to become 2. So now what we're going to do is negative 4 over 2 is negative 2 over square root 1 minus 4x. And that's our answer. That's our answer.